Hi, let's agree that in this movie we don't set ourselves the task to cover all that certainly falls under the subject, the development of monitoring and especially control redundant systems. Too wide and deep is the subject and so difficult. And you know about the time limit that exists for publishing movie on the video hosting. So let's look at an example of a small project of redundant system based on trace mode double force RTM running on two PCs. The lower level of the system represented by the remote input model I7017 to the first analog input of which is connected the output of special force signal generator AFG 72005. Visual control of that is happening is with the digital oscilloscope. The address of model in the RS485 network is 1. The data format is engineering. The connection between the both PC and model is via RS232 through interface converters. I7520 connected to the serial ports COM1 of the both PC. The first, the second. Let's show the implementation in this project of synchronization mechanism for real-time data, computational procedures, and for the contents of the files SCADA archive and alarms report. The algorithm of the switch reserves left by default. Please remember that the development of project with redundant nodes, you should only use the professional version of the integrated development system, trace mode. By the way, in our video used release 6.10. For running such project, need to use the profilers from IDE or regular, with the help of runtime models, trace mode, double force, real-time monitor, pre-installed on two PCs, as we have. Let's launch trace mode IDE and then download the previously prepared project with the name double force new EN. In short, it looks like this. We can see two nodes RTM1 and RTM1 reserve 1. As a reserved node is the twin brother of the node RTM1, then watch it became only at the end of the review of our project. Let's open the node for editing and go over the tabs. Main recalculation period is 20 milliseconds. In the network was configured network data exchange for the first network adapter with project code 33. Archives tab was configured archive with the name set1 with the default settings. The next tab, alarm report dump parameters. Alarm reports with the name alarms.txt with the setting by default. The last two tabs, timeouts and extra, left by default. The primarily concerns that the redundancy algorithms reswitching of reserves based on the mechanism of a network sniffer left by default too. A few words about the used I/O device. To do this, let's navigate to the layer Sources Receivers. Open it, and we can see distributed models. Open it, I7000 family. Open it, this is our model, I7017. Open the group for editing and find that the left all the default settings. Returning to the layer system, And we can see the channel groups with the name I-7017A with the three small channels linked to analog input from our analog input remote model. All channels in the group configured the same. Let's open the first. We set the limits and internal boundaries. Also, we set using the archive with the number 1 and alarms report. There, in the node RTM1, we can see a group of COM ports, which presents a description of the used serial port COM1 with the such settings. For the alarm report message for our channels was created group message dictionaries, and the dictionary with the name for float. It is specified in the field alarm dictionary ID for any our three small channels from the group I-7070A. Look here. The other I/O devices in our projects does not exist. Now let's look at the contents of the channel group with the name call. Here present a procedure for computing internal statistics using the channel call with the call type local statistic. Program request statistics and auxiliary channel minder linked to the respective internal generator. Channel local statistic links to the channel A in number 1. Remember, it is the first analog input of module I-7017, which read output voltage of the special form signal generator. That's we will analyze it. Let's open our channel for editing and look inside. Here it is necessary to pay attention to the value of the attribute parameter, as well as for the calculation period of this channel. In the tab Archiving, we can see description of the first, third archive, and finally the arguments of our channel. From the whole list, we will be interested in the minimum, maximum, mean, and standard deviation. The time interval for processing is set by program. Request statistics. Arguments of this program will be the next. The program is created in function block diagram language. Whether you want to be explanation for program, I think not. Simple. Probably you noticed that the title of the both considered groups of channels includes in brackets what synchronized call and I-7070A. It means that we have entered the channels into the mechanism of real-time data synchronization and algorithmic synchronization between redundant nodes. Why the need for synchronization? It's clear. In order to the data and algorithms synchronously updated on the node that in a state of hot standby 2. By the way, the both nodes RTM1 and RTM1 reserve 1 are absolutely equal, but who of the two of them will be the main decides by the order of startup. Each launched node has 1000 milliseconds by default for detection of a partner in the network. If one is not found, then the node sets itself to work state, connects all channels that have links to the I/O devices, and begins to perform work. If during startup the redundant partner will be found, the starting node sets itself in a subordinate state trace and begins to receive data from the main partner via the redundancy synchronization mechanism. At the same time, it channels link to the I/O devices not connected to sources receivers. The node in the state trace continuously monitors the node in state work. However, as soon as main will disappear from the network for time longer than 20 seconds, as a subordinate immediately sets himself from a state trace to state walk and thus will be take the controls. Well, let's back to synchronization. It's clear that the time delay between the data in the state walk and state trace nodes will take place because miracles don't happen we know about. Well, in order to include any channel to the mechanism of synchronization, we need to specify the attribute sync dump to state sync. Synchronization is performed in a separate network thread with the maximum achievable flow rate. Monitoring for the synchronization we will talk further. Thus, all channels in the both our group call and I7070R are marked accordingly. Now, monitoring for all internal processes will be performed with the help system and diagnostic variables. Look, the first group, the second and the third. Let's begin with the monitoring of out of sync time on our nodes. Let's open and open online help. Our parameter is 1. So, in the corresponding channel, we will observe in milliseconds the sync time between walk and trace. Let's continue. Diagnostic for redundancy represented by a list of variables. The first three are must be linked to the class call channel with the call type channel group request and are designed for data exchange between redundant nodes. For example, if you form the argument values of the call channel linked to redundant 32 val on a one node, then your partner on the other node can see them on the same arguments of the call channel linked to redundant 32 val other. The arguments of the call channel linked to redundant 128 val, the both nodes are available for read and write. 32 and 128 are maximum number of used arguments. With the rest we'll do so. Let's open online help again. Well, in the group service redundancy, we can see the one variable status current. In channel link to our variable, we will monitor the status of the current node. For clarity, let's resort to the help again. Okay, let's remember and look to configuration of our RTM1 reserve 1 node. The difference is observed only in the last digit of the IP address. Archives, alarm, report, timeouts, extra. The same as for RTM1. 10, 11. Okay, For those of you who is asking the question, excuse me, but how to sync the archives and alarm report? We have an answer. This is set in the nodes configuration files. For example, using Explorer, let's open folder of our project. For node RTM1, here we can see a file with a fixed name tmcom.xx.cnf. Let's open with the help notepad. Here is the content and necessary comments. Synchronization mechanism, TCP, synchronization for alarm reports, for archives, and so on. What is the 600? It's a time lag in seconds for archive data of the work node to transfer to the trace node. So we have a request the archived data for previous 10 minutes. Well, HMI for our project has 3 screens. The main, argument lists, diagnostics, arguments, and the third, alarm report. Very simply. Well, the experimental scheme is prepared. All connections between components are made. The voltage at the I/O device submitted. The instruments and the both PCs are turned on. On the signal generator sets noise mode with the amplitude 5 volts. Let's launch on the left PC runtime module double force RTM. Press the red man. Wait for the data on the trend and setting the current status as fog. OK. We will also monitor the process using a digital oscilloscope. Additionally, let's open, by help the main menu, RTM panel on the tab Log 1. Our runtime works for a few minutes. This time is necessary in order to calculate statistics, the save data to archive, and save messages to alarm report. OK. Now let's launch runtime module for the right PC. But without pressing the red man. Previously, we need moves pop-up screens on the main screen. Everything already, and now let's click to the red man and begin to observe what is happening. Left PC in the status work, and the right PC moved to trace. Wonderful. In the tab Log 1 at the left PC, we can see the synchronization process of archive and alarm reports files. On the trend at the right PC, we can see works of real-time data synchronization mechanism. By the way, all numerical characteristics of the synchronization processes are available on the diagnostic screens for left and right PCs. Okay, let's change the amplitude of the noise, at the same time looking at the both screen and on oscilloscope. In our case, the delay of a few tenths of milliseconds allowed for synchronization visually not fixed. Well, now let's experiment with the nodes. First, let's stop and unload the left PC and see how will be performed the switching hot standby node on the right PC from state trace to work. Attention. Work. Without delay. Let's unload and reload again on the left PC. Double force RTM. Let's launch again. Look here. Trace. Synchronization. Real-time data synchronization mechanism on the left PC. Well, we performed the analysis of redundant monitoring system prepared in the SCADA trace mode and tested it in real work. Of course, the development of highly reliable systems will require of deciding a much wide range of tasks, including, for example, creating custom algorithms of switching of reserves. However, let's remember that we are not Hollywood, and let's finish our movie. Thank you for your attention. Bye.